Hi, my name is Georgi Radulov and I would like to make a note on the reversed diode current. So, reversed mode is when we have an external energy source and we connect the positive side of the voltage to the N side of the PN junction diode and the negative side to the P. Then the externally created field adds up with the built-in internal field, the existing built-in internal field, resulting in a much larger electric field. This also results in enlargement of the space charge region. So the potential barrier for the electrons on the N side to diffuse to the P side is increased, and virtually it becomes impossible for the majority carriers electrons on the N side to diffuse to the P side. Even more, here if we look at the vicinity of the space charge region on the P side, the existing minority carriers, electrons, so the electrons are the minority carriers in the P side, they are swept to the other side through drift forces due to the increased electric field. So if we look at the concentration on the P side here, this is the concentration of minority carriers electrons, and this is their, if this is their normal thermal equilibrium level, what happens is that in the vicinity the concentration reduces even more. And this can be calculated with the formula that we derived in the previous videos. So now the electrons, the minority carriers, actually drift to the other side due to the internal and large internal field. As we increase the reverse voltage VR and the electric field becomes even stronger, the concentration of minority carriers at the border with the space charge region decreases until it reaches 0. So, and you can see that this value can be easily achieved if VR gets higher than the thermal voltage, because this ratio is the exponent of the function. So this means that at certain point the reverse current is supposed to saturate, and this indeed is what we defined as reverse saturation diffusion current, which is shown in the other picture. So this is the volt ampere characteristic, and this is the forward voltage, and the reverse voltage VR is in this direction. And you can see as we increase VR here in this picture, the current saturates. And this is because the concentration of minority carriers at the border of the space charge region on both sides reached virtual 0. Virtually there are no minority carriers to be drifted to the other side. However, in practice, what we see is that there is a dependence of the reversed diode current on the reversed applied voltage. So there must be another mechanism that constitutes the reversed current. And this is the generation current, the reversed generation current. Now, what happens, and what is the dominant process actually, is that inside the space charge region there is a thermal generation of whole electron pairs. So keep in mind that the space charge region is not only the ions due to the dopants, but there are still silicon atoms. So in normal temperature, 300 kelvins, it is statistically possible that an electron acquires sufficient energy to detach from its silicon atom. Hence, Hall electron pair is created, and this is the generation of Hall electron pair. Now, this Hall electron pair finds itself in a very strong internal electric field. Hence, drift forces act on the electrons, and the electrons, due to drift forces, are swept in this direction, while the generated Hall, due to drift forces, is swept in the other direction. So as the Hall propagates in this direction, here in the metal plate, it is exchanged for an electron. And here, this is how the generation current then propagates. So the electrons start from here, and they travel through the wire. Here they are exchanged for a Hall, which is coming in this direction, majority carrier in the p side. And they are generated inside the space charge region due to a simple thermal generation. Then the electron that is also generated travels due to drift forces in this direction. Keep in mind that the electric field is reversed in this direction, so the electron drifts inside this, in this direction, and here through the metal plate it completes its journey to the positive side of the externally applied reversed bias voltage. So now if we look back at the volt-ampere characteristic, what we see is that the reversed current is actually larger than predicted due to the diffusion, and also it depends on the reversed applied voltage, this gradient. And this is because if we apply larger reverse bias voltage, the internal electric field increases and the area of the space charge region increases. Now, larger area means larger statistical chance for the generation of Hall electron pair, hence larger current. And when I say large, I really mean very small current, but in comparison with the reverse saturation diffusion current, the generation current is larger. Both constitute the reverse diode current. Thank you very much for your attention.